In this video, you're going to learn about a brief introduction to earthquakes. Earthquakes are events that occur due to the movement of Earth's crust. And we need to remember that Earth's crust is the topmost layer of the Earth, and it consists of the rock that makes up the continent and the ocean floor. So simply put, it's the ground that we walk on. And this picture is showing the result of a very devastating earthquake that completely shifted and moved Earth's crust. Now, when earthquakes occur, there's always an epicenter of the earthquake, and that's the location on Earth's surface directly above where the earthquake originated. So if we look at this diagram, we have two locations we need to point out. First is where the earthquake took place, which is beneath the surface within Earth's crust. We call that the earthquake origin. Directly above that point of the origin of the earthquake, on Earth's surface, we call that the epicenter of the earthquake. Now, earthquakes, when they happen, they generate energy waves that are essentially released from the epicenter of the earthquake, and they travel outward in all different directions. So what we have here in this picture is first the earthquake origin, which happened below the surface but still within Earth's crust. Directly above that point on Earth's surface is the epicenter. Here we're highlighting the crustal movement, the movement of the crust due to the earthquake. Now, those red circles that start at the epicenter and travel outward represent those earthquake waves. You need to realize that the earthquake happens in one location in Earth's crust, but those waves travel to other locations. So even if you are not at the epicenter of the earthquake, you can still feel the movement of Earth's crust because those earthquake waves travel to different locations. What's also important to understand is when you are in an earthquake and you feel the shaking of the ground and the movement of different structures, that's because of the movement of those earthquake waves. That shaking is caused as those earthquake waves pass through the location that you are within. Now, this diagram is showing you an example of an old earthquake from the 1800s, and we have different color-coded parts of the map to show you how much damage and how violent the earthquake was for different locations. Red is the most extreme damage of the earthquake. Orange is a little less extreme, but still really powerful. And then, of course, the yellow and then eventually the greens are showing moderate impacts from that earthquake. So the epicenter is, of course, where you have those red colors, really extreme damage from that earthquake. That's where the epicenter was. As the earthquake occurred, the earthquake waves traveled outward in all different directions, so cities that weren't at the epicenter still felt the effects of the earthquake, but they were less significant the further away you go. So simply put, the further you are from the epicenter of an earthquake, the less damage you'll get and the less that you'll feel. The closer you are to that epicenter, the worse the earthquake is going to be for your location. Now, we need to figure out why earthquakes are so important for scientists to study. This animation is going to show you the movement of earthquake waves throughout Earth's interior. There are two types of earthquake waves in this animation. The dark blue represents P waves, and the light blue represents S waves. You don't have to worry about knowing the difference between P waves and S waves. We just need to know that they are certain types of earthquake waves that travel throughout the Earth during an earthquake. So as we look at this animation, we have the P and S waves travel throughout Earth's interior, and some waves even make it to the other side of the Earth. So now we're going to look at a snapshot of this animation so we can analyze this a little bit more specifically, because while this animation is on pause, as we have here in this image, we can see that there are two very big differences between how the waves traveled. First, let's look at those light blue waves. You'll notice that those light blue waves stop completely at that orange layer. They don't go through. They're not traveling through that orange layer, while those dark blue waves did. On the other hand, you can also see that some waves traveled faster. Those dark blue waves are traveling at a lot higher speed than those light blue S waves are traveling. So the earthquake waves can have these differences based on the layers that they're going through. Sometimes their speed will change, and also sometimes certain waves just don't go through certain layers. And this helps scientists out a lot. What scientists were able to conclude is they learned that S waves have a very special property that does not allow them to travel through liquids. So first, let's look at the layers of the Earth. We have the mantle in red, the outer core is in orange, and then the inner core is that bright yellow color. If we take a look at the outer core, you'll notice that's exactly where the S waves are stopping. Scientists were able to conclude, since S waves don't go through the outer core, they must have realized that the outer core is made up of a liquid. Now, the outer core is made up of iron and nickel. So it's not liquid water, it's liquid iron and nickel. So that when you hear liquid, don't think water, it's liquid metal. So this animation, or image rather, is showing you that earthquake waves can travel across the Earth. They just don't impact nearby locations. These waves can travel really long distances. Here's the epicenter of your earthquake, and these earthquake waves can travel through Earth's interior and make their way to the other side of the Earth. This animation is going to show you something very similar. Here you have an earthquake that happens in the crust, but those earthquake waves can travel to other layers and to other parts of the Earth that are really far away. So these earthquake waves can travel a really large distance. This helps scientists, again, figure out what is inside of the Earth. We have not even scratched through the crust. The crust is the only layer that humans have been able to explore. We have not gotten to the mantle, and then definitely not the outer core and inner core. So you might be wondering, how do we know what those layers are made up of, and how do we know if they're solid or liquid? Again, it's all because of your earthquake waves. This graph is showing you two lines, one in green and one in blue. And if we look at the green line specifically, you'll see that it stops at that outer core because, again, some earthquake waves don't travel through liquids, and that's how we can conclude that this outer core is liquid. We can also look at the speed of the wave, and the speed of the wave can be dependent on the material that is making up each layer, which is how we can determine how thick a certain layer is and what material is within that layer. So this diagram here, which is a very complete representation of the layers of the Earth and what their compositions are and how deep they are, was all constructed because of earthquakes and the earthquake waves. Earthquakes are really dangerous events, and we do not want them to happen. However, they have been very helpful in allowing scientists to figure out exactly what is beneath the crust that humans simply cannot get to.